The vertical line test says that if you can draw any vertical line so that it intersects a graph at more than one point, then the graph does not represent a function. If you can draw any vertical line so that it intersects the graph in more than one point, the graph does not represent a function. So let's check out, see how this works here. I've got a function, I've got something that's not a function because if I draw any vertical line, it passes in more than one point. If I draw any vertical line, it passes in more than one point. This creates something that is not a function. All right, so let me throw up three graphs, and you, for yourself, decide whether these are functions or not. So let me just quickly erase this and throw up three graphs. I've got the graphs here already set up. And the question will be, which graph represents a function? Whoops, excuse me. Which graph represents a function? Which graph represents a function? And let me put the three up for you. And I won't even put the equations, okay? We'll just simply draw them. So I'll place this here. Here we go. First is a picture or a graph that looks like this. The second is a graph that looks like this. It hits at 1 on the y-axis, and it's an upside-down parabola. So the first is a graph of a V on its side, the second is an upside-down parabola, and the third is a wavy shape. 1, 2, 3, 4. 1, 2, 3. Goes up, comes down, comes up again. So it looks like this. Okay, so those are my three graphs that we're going to look at. So I'll erase the other two. So while I'm erasing these, I want you to be thinking, which of these are functions and which of these are not functions? And how can you tell you're going to apply your vertical line test? So which of these are functions and which of these are not functions? So let's see. What do you think about the first one? Is this a function? No, because if you take any vertical line, it will hit in more than one place. So this is not a function. And the second guy, is this a function? Yes, because if you draw any vertical line, it will hit in at most one place. So yes, this is a function. And the third one, what do you think? If you draw any vertical line, will it pass in more than one place? No, so it is definitely a function. Yes, a function. Okay. You think you have the vertical line test down? Easy test. Test you'll never forget. Okay, so if you can draw a vertical line passes in more than one place, it is not a function. Well, regardless of whether we have functions or not, later on we're going to look at why functions are so important, and probably in the next video, but in the meantime, if you have any kind of graph, whether it's a function or not, you can always find what are called the domain and the range. In the definition of a function, we mentioned two words called the domain and the range. So the domain of a function or a relation doesn't matter. In any case, the domain, for our case and purposes here, is going to be your set of x values. It's your input values. But for all basic algebra courses, your input values are your set of x values. And your range is going to be the set of y values that corresponds to your relation or your function. And one of the neat things is when you have a picture, you can visually see what the range in the domain is. So let's take a look at the first example. If I said, even though this is not a function, it still has a domain. It still has a set of x values. And what would be that set of x values? Well, if you look here, if you check it out, this picture right here starts here on the x-axis at 0 and will take every x value after that. It will take on every x value after that. You can see that because this thing just keeps going and going and going. So we would say that the domain for this function starts at 0 and it goes to everything beyond it, all the way to infinity. This might be new to you, it's interval notation. But what it says is it starts at 0 and it goes to infinity. Another way to write that would be x is always greater than or equal to 0. Because if you notice in this picture, you never have negative numbers for x's that correspond to this graph. Okay, that's your domain. How about the range? The range, then, in this picture, well, let's see. As far as y values go, are you going to have negative y values that correspond to this graph? Sure you are. As you keep going down, you're going to find a y value that corresponds. And as you go up, right, as you go up the y-axis, you will find y values that correspond. So our range for this picture is all y values possible. And what are all the y values possible? It's everything from negative infinity to positive infinity. So another way to write that is in the interval notation, negative infinity to positive infinity. Let's take a look at the second picture and let's talk about domain and range. Domain, set of x values. Range, set of y values. Okay, x values. If I choose any x value, will I find its corresponding place on the graph? Will there be a place where the graph corresponds to it? Yes, if I choose any x value over here. And how about on this side? If you choose any x value and you go down, will you find a place where it corresponds to on the graph? Yes. This graph keeps going. See, it's an upside-down parabola, and it just goes and goes and goes forever and ever and ever and gets a little wider as it goes, but it keeps going. So we would say that the x values here can range all the way from negative infinity to positive infinity. So our domain for this second picture is all x values. X can be any real number, so that's negative infinity to positive infinity. Or you can write it in words, x can be any real number. And your range, let's check out our range in this picture. Our range, again, is the possible y values. So we'll start here with negative y values. If you choose any negative y value, will you find a corresponding place on the graph? Yes. Okay, you will have, so we'll start at negative infinity. We'll start way down here, and we'll keep going and going and going and going and going up until we get to the number 1. Can we go anywhere above it on the y-axis and find a partner on the graph? No. The highest that this graph goes on the y-axis is 1. So we stop at 1. And so our range would be everything less than all the way up to 1. And you could write that y is less than or equal to 1. You could also write it that way. It doesn't matter how you write it, either interval notation or with symbols, inequality symbols. So let's take one more look at this guy here. This is the domain and the range. Okay, the domain and the range. So on the domain, what are your possible x's? This thing has an endpoint here and an endpoint here, so it stops. So our domain, the x's, start here and stop here. They don't go any farther, right? They start here and stop here. So our domain would be 0 to 4. In between, you always have a place that corresponds to the graph. And our range, the y values, are stops down here at negative 3, stops here at positive 3, doesn't go higher, doesn't go lower. So our range, see if you agree, would be negative 3 to positive 3. Okay. Okay, so in words, just real briefly, that's how you get domain and range. You look at x-axis, you look at the y-axis and see where the graph goes in relationship to the x and the y-axis. I've got a real cool application that I want to show you then. It's on Fawn and it's